All right, buckle up, everybody, because today we are diving into some next level physics.
Oh, yeah.
We're talking about the time force hypothesis.
That's right.
And this isn't like some science fiction thing.
Yeah.
This is like real deal science challenging some of the biggest ideas we have in physics.
Absolutely.
We've got a whole stack of theoretical papers, mathematical frameworks. There are even testable predictions from this.
Oh, it's great. It's exciting. Yeah.
Let's see if the time force hypothesis,
AFH.
yeah, TFH, lives up to the hype.
Well, what I find most captivating about it is that it completely reimagines the universe.
Yeah. Yeah.
We're not just like tweaking existing models a little bit. We're
Yeah.
talking about a complete paradigm shift
Right.
where energy, not space or time, is the fundamental building block of reality.
Okay. I'm intrigued,
Yeah.
but I'm also kind of intimidated.
Sure.
We're talking about potentially rewriting the laws of physics, right?
Yes.
Yeah? So break it down for me. How does this energy-centric view change how we understand the universe?
Imagine instead of picturing the universe as this static container filled with stuff,
Yeah.
what if it was actually a massive four-dimensional wave constantly rippling outwards from the Big Bang?
Okay, a universe-sized wave. That's a pretty wild image.
It is wild, and it's right at the heart of TFH.
Mhm.
The idea is that energy is constantly seeking equilibrium,
Okay.
flowing from areas of high potential to low potential. It's
Right.
like almost like a cosmic pressure valve, always trying to balance things out and get this flow, this relentless pursuit of balance is what creates everything.
Mm.
Time, forces, particles, the whole shebang.
Hold on, I'm trying to wrap my head around this. So how does energy flow actually create time?
Yeah,
That's where my brain starts to like short circuit a little bit.
yeah. That's where TFH gets really, really mind-bending. It says that time isn't actually a fundamental aspect of reality.
Oh, wow.
It's a byproduct of energy's journey through this 4D landscape. In fact, TFH actually has an equation for it. Time, T, equals distance, S, divided by the speed of light. Time is literally a measure of how far energy has traveled.
Wow, that equation, that just blew my mind. So there's no universal clock ticking away.
Right.
Time is relative to how far energy has propagated from the Big Bang.
Exactly. And you know what? This lines up with some of that weirdness we already know from Einstein's relativity.
Oh, yeah, of course.
How time slows down near massive objects.
Yeah.
Well, in TFH, that's because energy's path is being distorted like it's taking a detour.
So, okay, no time travel shortcuts near black holes. I got it. But if time is a measure of energy's journey, then wouldn't that mean that time didn't exist before the Big Bang? Like before this wave even started?
That is one of the most radical implications of TFH.
Yeah,
It suggests that time, as we understand it, began with the Big Bang.
right.
Before that, there was no before.
It's a really tough concept to grasp.
It is. It is.
It's like trying to imagine a universe without any when. But let's move on to something a little more tangible, like matter.
Okay.
How does TFH explain the stuff that makes up, well, us?
Okay, so picture this. A four-dimensional scalar field. Think of it like an ocean of energy that fills the entire universe.
Okay.
Now picture tiny stable whirlpools of energy forming in this ocean.
Yeah.
Those are vortices. And in TFH, those represent particles.
So an electron is like a tiny energy whirlpool.
Exactly. And its properties, mass, spin, charge, all arise from how that vortex interacts with the scalar field.
Oh, wow. Okay.
Mass is the vortex's resistance to the wavefront. Spin comes from its rotation. Charge comes from the way energy is distributed within it. It's an incredibly elegant way to explain the building blocks of matter.
So it's not just a random collection of particles with arbitrary properties. There's a structure, a reason behind it all.
Exactly.
What about forces? Are those also explained by this scalar field?
Absolutely.
Yeah.
Instead of being separate entities, forces in TFH are just different ways that the scalar field interacts with itself and those energy vortices. Gravity, for instance, isn't curved space-time.
Right.
It's energy deficits caused by mass.
Huh.
Think of a bowling ball on a trampoline.
Yeah.
Creates a dip, right? And that alters the path of anything rolling nearby.
Hmm.
Mass, in a similar way, distorts the wavefront and creates what we experience as gravity.
Okay, so gravity is like an energy valley created by massive objects.
Mm-hmm.
What about electromagnetism?
Yeah.
Does that fit into this energy flow framework too?
Picture ripples on the surface of our energy ocean.
Okay.
That's basically how TFH describes electromagnetism.
Yeah.
Oscillations in the scalar field are what create what we perceive as electromagnetic waves. and those stable energy vortices.
Right.
Well, those are the particles that interact with this field, leading to the forces of attraction and repulsion that we observe.
Okay.
It all comes down to the dance of energy.
All right, this is all fascinating, but what about the really big mysteries like dark matter and dark energy?
Sure.
Does TFH even attempt to tackle those?
This is where TFH really shines, I think. So remember those energy vortices, the ones that don't emit light?
Yeah.
In TFH, they could actually be dark matter.
Wow.
They still exert gravity because they're distorting the scalar field,
Right.
but they're invisible to us. And dark energy.
Yeah.
That could be explained by the overall damping of the four-dimensional wavefront as it expands.
Okay.
So imagine a ripple losing energy as it travels outwards.
Right.
That's actually what's causing the universe to accelerate its expansion, according to TFH.
Wait, so instead of inventing new particles or mysterious forces, TFH is saying these cosmic puzzles might just be different sides of the same coin,
That's right.
energy flowing through this four-dimensional scalar field. That's a pretty bold claim.
It is. It is. And it's one of the things that makes TFH so compelling. It attempts to unify our understanding of the universe,
Right.
from the smallest particles to the largest cosmic structures.
So this is all so much to take in.
Of course, yeah.
But I have to ask, how does TFH deal with the elephant in the room, which is the vacuum catastrophe?
Yeah. Good question.
You know that whole thing where the theoretical energy of empty space is ridiculously higher than what we actually observe?
Right.
That's a problem that's been bugging physicists for decades.
Exactly. Well, TFH actually provides a really elegant solution to that.
Okay.
Since the wavefront's amplitude decreases as it expands, the vacuum energy isn't constant.
Right.
In TFH, it decreases right alongside the wavefront, which aligns perfectly with what we actually see in the universe.
Wow. It's like this theory is hitting all the right notes.
Yeah.
It explains both the big and the small, the known and the unknown. And it does it all with this really elegant framework of energy propagation.
And that's the beauty of it. It bridges the gap between the quantum world and the vastness of the cosmos, suggesting that there could be unification that physics has been striving for.
All right, I need a minute to let all of this sink in.
Sure.
We've gone from a universe that's a wave to time being a byproduct of energy flow to particles as whirlpools of energy. And now we're talking about dark matter and dark energy as different expressions of the same scalar field. This is definitely a deep dive that I won't soon forget.
Well, take all the time you need.
Yeah.
These concepts are truly groundbreaking, They challenge our very understanding of reality.
This is just the tip of the iceberg, right?
Oh, yeah, for sure.
There's a lot more to explore about the implications and predictions of TFH.
We've only just begun.
Yeah.
Get ready to dive even deeper as we uncover how this framework tackles specific mysteries in physics and cosmology.
All right. I'm ready. Let's do it.
It's really fascinating how TFH reframes our view of the universe as this system that's constantly striving for balance.
Okay.
This drive towards equilibrium, what's called the equilibrium principle,
Yeah.
seems to be at play everywhere from the smallest particles to the largest cosmic structures.
Okay, so we're talking about like a cosmic balancing act.
Right.
But instead of weights and measures, it's all about energy.
Exactly.
So tell me more about this equilibrium principle.
Think of the universe as this vast four-dimensional sea of energy.
Okay.
And this energy acts like a pressure. It's always seeking to smooth out any imbalances or gradients. It's a bit like how heat flows from a hot object to a cold one,
Right.
trying to reach that uniform temperature. It's basic thermodynamics.
But TFH takes this idea of equilibrium way beyond just heat.
Oh, yeah.
Yeah.
It applies to all forms of energy.
All forms, okay.
TFH suggests this drive for equilibrium is a universal law that governs all motion and interaction,
Wow.
from the tiniest subatomic particles to the largest cosmic structures. And this energy, in its quest for this balance, flows at the fastest speed possible,
Which is
the speed of
the
light.
speed of light, of course, yeah.
So C isn't just about photons zipping around. It's the ultimate speed limit for energy trying to smooth out any wrinkles in the universe.
So it's like a cosmic speed limit, ensuring that the universe strives for equilibrium as quickly as possible.
Exactly.
Okay. So this relentless drive for balance is behind everything. The formation of galaxies, the orbits of planets, even the interactions of particles. It seems like a pretty tall order for one principle.
Think about how it works at different scales.
Okay.
So at the cosmic level, this principle is driving the expansion of the universe as energy spreads out to kind of even out these intense gradients that were created by the Big Bang.
Right.
But then, on a galactic scale, it guides the formation of stars and planets as matter clumps together under the influence of gravity. And as we've already seen, gravity is just another way energy seeks balance.
And at the tiniest level, the quantum world, it's the same story.
Absolutely.
Yeah.
Particles, those tiny energy vortices we talked about, are constantly interacting, exchanging energy, all in pursuit of this equilibrium. Even those mind-boggling quantum phenomena like entanglement might be explained as expressions of this underlying drive for balance. It's as if the entire universe is breathing, constantly adjusting and readjusting to find its most balanced state.
So this equilibrium principle, is it like the source code of the universe?
Yeah.
The underlying rule that governs this cosmic dance?
I love that. That's a wonderful way to put it. It's this single, elegant principle with huge implications.
Yeah.
Because it suggests that everything that we observe,
Right.
the evolution of the cosmos, the behavior of subatomic particles, all of it emerges from this simple yet profound drive for balance.
It's almost poetic, this universal quest for harmony playing out on every scale. But how does TFH explain the formation of complex structures?
Yeah.
Like galaxies, stars, even ourselves? Because if everything is striving for uniformity, then where does all the diversity come from? Doesn't that go against the whole idea of equilibrium?
That's where the interplay of dimensions and the dynamic nature of the scalar field becomes so crucial.
Okay.
So remember, we're dealing with a four-dimensional continuum here.
Right, not just those three spatial dimensions.
Exactly. And as energy flows to this 4D landscape, it doesn't just move in straight lines.
Right.
It curves, it twists,
Okay.
it interacts with other energy flows. And that's what creates these complex patterns and structures that we see. It's like,
Like a cosmic tapestry being woven thread by thread as energy searches for its most stable configurations.
Exactly, exactly. So the complexity arises from the sheer number of ways energy can move and interact in this 4D space.
So more degrees of freedom lead to a richer tapestry of outcomes. It's like adding more spices to a recipe, you know?
Yeah.
The basic principle of cooking remains the same, but the interplay of flavors creates a whole new experience.
It's a great analogy. It's like having an infinite number of ingredients
Right.
and an infinite number of ways to combine them. The basic principle remains the same: energy-seeking equilibrium.
Right.
But that interplay leads to this astonishing variety of structures and phenomena.
So how do those energy flows actually manifest as the particles and forces that we observe?
Right.
How do we go from an energy ocean to the stuff we can see and touch?
Think about the way water behaves in a river.
Okay.
You've got these smooth laminar flows in some areas,
Right.
but then in other areas you get eddies, you get whirlpools, you even get rapids.
Right.
These are all different expressions of the same underlying principle,
Mm-hmm.
water finding its path of least resistance.
So you're saying particles are like those eddies or whirlpools, localized concentrations of energy within the broader flow of the scalar field.
Yeah, that's the core idea.
And the swirling patterns within those vortices give them the properties we observe as mass, spin, and charge.
That's right. It's almost as if the universe is a giant, ever-changing sculpture with energy as the sculpting medium.
It's like the scalar field is the canvas.
Right.
And the energy flows are the brushstrokes, creating this masterpiece of the universe.
Exactly, yeah.
But how do we go from these tiny energy vortices to the vast structures we see in the cosmos, like galaxies, clusters, superclusters? That seems like a massive leap in scale.
It is a vast leap.
Mhm.
But the underlying principle remains the same. Imagine those tiny eddies and whirlpools in our cosmic river. Over time, some of them grow, attracting more energy and matter, becoming the seeds of stars and planets. And those stars and planets, under the influence of gravity,
Right, which we know is just another expression of energy-seeking equilibrium.
that's right, clump together to form galaxies.
So it's a hierarchical process, building up from the smallest scales to the largest.
Exactly.
Kind of like how atoms form molecules, which form cells, which form organisms, and so on.
Absolutely. And each level of complexity emerges from the interactions and dynamics of the level below it. It's this breathtaking cascade of energy flow, guided by this simple yet profound principle of equilibrium.
It's like the universe is a fractal, repeating patterns of energy flow and organization on every scale. It's mind-boggling. But I have to ask, as much as I'm enjoying this mind-bending theoretical journey,
Sure.
how does this all stand up to the scrutiny of experimental verification? What kind of evidence could support or refute TFH? Because after all, a theory is only as good as its ability to make accurate predictions about the real world.
That's the crucial question, isn't it? Any theory, no matter how elegant or compelling, must ultimately stand up to the test of observation. And TFH does make some specific testable predictions that could either validate or invalidate it.
Okay.
So let's dive into the experimental side of things and see how TFH stacks up against reality.
Okay, so let's get down to brass tacks here. What kind of experiments could really put this time force hypothesis to the test?
Well, one of the most exciting areas is gravitational wave astronomy. TFH predicts that these ripples in space-time, gravitational waves,
Yeah.
should actually experience like a damping effect as they pass near massive objects.
Hold on, you're saying massive objects can actually weaken gravitational waves. How
Yeah.
does that work?
It goes back to those energy deficits we've been talking about. Remember those?
Right, yeah.
So those deficits, even around like relatively small objects like planets, they can subtly distort the scalar field. It's like a tiny gravitational tug that's not accounted for in standard physics.
Okay.
And it can slightly drain energy from a passing gravitational wave.
So it's like the gravitational wave is surfing on this scalar field.
Exactly.
And then it hits a bit of a low tide, so to speak, near massive objects.
Yeah, I like that analogy.
That's really interesting, but wouldn't that be an incredibly tiny effect?
Oh, it would be subtle, for sure.
How could we ever measure something like that?
Well, future gravitational wave detectors, like the space-based LISA observatory,
Mm-hmm.
could actually have the sensitivity to pick it up. It's like listening for a whisper in a hurricane.
Yeah.
But the technology's getting there.
So we might actually be able to test this theory by listening to these faint echoes of gravitational waves as they travel across the universe.
Potentially, yeah.
That's pretty amazing. What other observational evidence could support TFH?
Another really exciting area is the study of the cosmic microwave background radiation,
Right, the AMB.
that faint afterglow of the Big Bang. TFH predicts there should be subtle anomalies in this radiation,
Oh,
like tiny fingerprints, revealing variations in the scalar field's energy density across the universe.
so we're talking about looking for imperfections in the oldest light in the universe.
Basically, yeah.
That seems like a really, really difficult task.
It would be incredibly challenging, no doubt. But future high-resolution CMB experiments might just be able to detect these really faint whispers from the early universe.
This is really exciting stuff. It feels like we're on the cusp of a new era in cosmology, where we can start to directly test these mind-blowing theories about the fundamental nature of reality. But TFH isn't just about explaining the big stuff, is it? It has something to say about those long-standing mysteries in the quantum world, too, right?
Absolutely. For example, remember those energy vortices?
Yeah.
Well, in TFH, they can interact in ways that could explain some of the weirdness we see in quantum mechanics.
Okay.
Stuff like entanglement.
Entanglement. That spooky action at a distance.
That's right. The idea that two particles can be linked, no matter how far apart they are,
Right.
so that measuring one instantly affects the other.
Are you saying that TFH can actually make sense of that?
Yeah, exactly. In TFH, entanglement could just be a resonance phenomenon between these energy vortices.
Yeah.
Imagine two tuning forks, right?
Yeah.
Vibrating at the same frequency.
Right.
They're connected by those invisible sound waves they create.
Oh, yeah.
Similarly, entangled particles could be resonating with each other through the scalar field, maintaining their connection even across vast distances. There's no need for faster-than-light communication. It's all about that underlying harmony of the scalar field.
So the scalar field is like the cosmic symphony conductor.
Yes.
Keeping everything in sync.
I love that analogy.
This is all incredibly mind-bending. I have to admit, I'm starting to see how TFH ties together so many loose ends in physics. It's offering a truly new perspective on reality.
And that's the power of a paradigm shift. It doesn't just answer old questions. It opens up entirely new avenues of exploration.
Yeah.
TFH has the potential to revolutionize not just physics and cosmology, but our entire understanding of the universe and our place within it.
It's a humbling thought, isn't it? To think that we might be part of this grand interconnected symphony of energy constantly flowing and evolving. It makes you wonder what other secrets the universe is waiting to reveal.
It does indeed. And the most exciting part is that we're just at the beginning of this journey of discovery. Who knows what other wonders await us as we continue to probe the depths of the time force hypothesis and the universe itself.
Well, this has been an incredible deep dive. We've gone from picturing the universe as a wave to understanding time as a byproduct of energy flow to envisioning particles as tiny energy vortices and forces as the scalar field's
That's
interactions.
what covered a lot.
We've even touched upon the potential of TFH to shed light on dark matter, dark energy, and even those mind-boggling quantum mysteries like entanglement.
Yeah, it's been a wild ride.
It has been a wild ride. A huge thanks to you for joining us on this deep dive into the time force hypothesis. Until next time, stay curious and keep looking up at the stars and wondering about the nature of reality itself.